Hello, this is a debrief of the day 2 example about the big table of numbers about what cars do you like and what gender are you. And this is on page 6 and 7 of the student packet for A+ College Ready. So this is a debrief because one of the things that we'd like to do is you could do all of the mathematics and find all the answers and make all the charts, but we need to make sure that we put the words together with what you're doing. So when you have columns and rows like this, this is called a two-way frequency table. And the reason it's called a two-way frequency table is that your frequencies are going two ways, horizontal and vertical, right? So it's a two-way frequency table. So, I mean, this is just a table of categorical data, right? But if you didn't know it was called a two-way frequency table, and somebody might say that and you go, well, I don't know what that is. And I just wanted you to know what that was so you didn't feel caught off guard. Okay? So there's your two-way frequency table. Also, these totals right there are in the margin, and they're called, I'm going to put it down here, they're called marginal distributions or frequencies. And if you find a marginal, well, they're not frequencies. Yeah, they are. If you find a marginal probability, then that's the total. That is the total of a row over the whole. Then that's a marginal probability. So a marginal probability is when you use the sum of one row over the total of the whole population, or the sum of a column over the total population. That's called a marginal probability. And you're going to talk a lot about that later, but I just want to kind of put together something we're doing now with something you'll see later, okay? Let's see what else I'm supposed to, okay. So when you have a row and a column meet, that number is called the joint distribution. Did not plan for that space well, did I? So when the column and the row meet or they join, it's called joint distribution, because that is the distribution of the data that they join together, right? Okay. So that's kind of cool. That's some new vocabulary, and that is in the notes before this page on page 5. But I wanted to show you where it was in the table because that gets confusing, all these things. Remember, this is a relative frequency in percentage, right? And that is, that's a marginal relative frequency right there, because that is the total over the total of the row over the total population. Sometimes I'll do something and put that in like happy cloud because that is the total population. And that helps me kind of make sure that I use that as my denominator if they ask me about the whole population. Which brings us to, how do I write this conditional probability that we talked about a minute ago? Or, yeah, conditional distribution, conditional probability. All right, so when we wrote this, we just kind of said it's female and American, and we didn't really write this well. We found the answers, and that's fine, because that's what we're supposed to do. And we made a chart of it. Great, go us. However, I really would like to see us write this in more statistical symbols, okay? This isn't hard. I swear this is not hard at all. This will actually help you communicate this easier in symbols. So if I want, excuse me, the answer to, given that the respondent is female, how do I know if she likes the American cars? I write P, and that stands for probability. And what's funny is that you put the given after. So this is female. And then what you want, like American, goes first. So this line kind of means given. I'm going to write that. It kind of means given. So when you read this probability, you say, what's the probability that they liked American cars given that it was a female person? And this tells you what the denominator is. And it gives you a new population, right? You can only look at the females, not the whole population, but there's just new population of females only. And that's why this is called a conditional probability or a conditional distribution. Because we said you can only look at the females. You can't look at everybody. You can't look at the 1,154 people. You can only look at the females. So when you see this bar, that means that I can, remember how we did this? We'll do it again just for emphasis. This is really huge. If you get this, you're like, oh, this is not hard at all. So if it says only look at females, that means I got to cover all that up, right? I can only look at females, and that means that that total for that column is what I need to look at. Okay, and notice that the joint probability actually was our top, because when you do this and you say, oh, I can only look at that because it said only look at females, when you go grab the American from that, that's where the American and the female join. So really, the conditional probability is really a joint probability over a marginal frequency, right? A joint frequency over a marginal frequency. Crazy, huh? I'm using all these new words. Okay. Let's see what else I need to tell you. And put in pink for you. I think that's it. Oh, make sure, make sure that next time you're asked to do this conditional distribution, you can't see what I'm talking about. Next time you're asked to do this conditional distribution, use this symbolization. So, for example, I'm going to do this one just to kind of show you again how you do that. That's the probability of, and this was given that they were male, so that's the second part, right? That's your population. And this was European. And again, you read this. What is the probability of liking European cars given that you were male? And I just want to do this for emphasis, because if you get this right, boy howdy, it's going to be fun and easy. If it says given male, that means you cannot look at anybody else but the males, right? Cover everybody else up. And the total of this column will be your denominator. And these joint probabilities, where the American and the male join, or the European and the male, right? That will be your numerators for this conditional probability. You put a condition on the population.